Hello, everybody, and welcome to week 3 of RobotGo. So this week we decided to go more into the hardware side of the robot and to just familiarize yourselves with the hardware and kind of like the main hardware components that we're going to use to make the robot go. In addition, we spent the week looking at our first major piece of hardware, which is the gamepad, and we looked into kind of like how the code works and how we can make code for the gamepad to actually read from it, and hopefully in the future, use the gamepad to control other pieces of hardware on the robot. So, quick review from last week. If you want to check out the last video, what we did was we went over GitHub. We did an intro to GitHub, so some of the main commands here, adding, commit, push, pull, clone, branching. And we also spent some time looking at Android Studios, specifically where we put all of our files, where you write the code. And like I said, if you need to review any of that information, you can check out our YouTube channel, and we have the link to the YouTube right here. So what we're going to do today is we are going to begin by looking at some of the first hardware. That includes the control hub, the expansion hub, the driver station, and the gamepad. And we're going to take a deep dive into the gamepad itself. We're going to look at some sample code for the gamepad. We're going to look at the class definition of the gamepad. I'm going to show you how to get to that. And I'm also going to show you guys, hopefully give you guys a foundation for being able to write your own code for the gamepad in the future. So with that, let's get started. So like I said, we're going to start with some of the hardware. And, you might be wondering to yourself, like, why are we even going over this, right? Like, isn't this supposed to be a software class? Well, the reason why we go over the hardware is because, very simply, you won't be able to write software for hardware you don't understand. How are you going to know how to control a motor if you don't know how to access that motor in code, like the motor object, or what methods you can call on that object? What can you actually make the motor do? This is why we take the time when we code for the robot to get a basic understanding of what it is that we're trying to make work. And that's kind of what I want to do in this course, is introduce you guys first to the actual hardware, right? The different pieces of hardware, and then go over how to do it in software. Because ultimately, you're going to need both an understanding of hardware and an understanding of software to make the robot go and do what you want it to do. So to that end, the first pieces of hardware that we're going to talk about are the control hub and the expansion hub. So the control hub and the expansion hub, these are basically, or let's start with the control hub. The control hub is essentially the brain of the robot. You can kind of think of it as like a microcontroller for the robot. The control hub, what we do is it allows us to basically connect all the hardware devices that we want to connect to it. So I have this image right here, which I just made a little bit bigger, because I want to show you guys what the control hub looks like and what you can do with it. So right here in the center, this is our control hub. You can see it looks like this, and this gets actually mounted onto the robot. And you can see that you can connect all of these different things to it. So you can connect these motors here. They're showing you the different types of motors you can connect. This is where you plug in your battery. You can have a servo. You can have some color sensors. So the control hub is where you're actually going to connect all of the pieces of hardware that you want to control. The control hub is also important because this is what we're actually going to connect to upload our code. Essentially, when you want to upload code to the robot, you can do it in one of two ways. You can either take a wire, like a USB to USB-C, connect it to the back of the control hub, approximately where my mouse is, and then in Android Studios, you can actually upload the code. There'll be a little play button at the top, and I'll show you guys where that is in just a minute. But that's how you're going to upload your code to the robot. Now, where the expansion hub comes in is, as the name suggests, an expansion hub basically gives you more ports if you want to connect more devices. So like, for example, imagine that you have a robot and you're using like 4 motors to run the 4 wheels. Well, if you want to have like a lift mechanism that uses a motor, you're going to be limited by the number of ports you have. But with the expansion hub, so here, I'm going to increase the size of my diagram here. With the expansion hub, you essentially double the number of motor ports that you have available to you. So it expands the number of ports that you have. You see? So we're going to use an expansion hub and a control hub a lot over the course of this course, just because these are the main piece of hardware you need to actually make your robot move. The expansion hub is optional. I mean, if you can make your robot work with just 4 motor slots, then that's fine. But you can also use an expansion hub just to give yourself more options. So long story short, control hub, the expansion hub, basically the brains of the robot. Now, in order to configure the control hub, because when you get like a brand new control hub, you have to do some configuration to it. You need to use a tool called the Rev Hardware Client. The Rev Hardware Client is a software tool that allows you to connect to the control hub, and it basically allows you to look at it, configure some settings, and basically look at, what you need to do. It gives you the options to configure the control hub to how you want it. So right there, you can connect to the expansion of the control hub and you can configure them. Unfortunately, the the Rev Hardware Client only works for Windows. There is a workaround called ADB, which you can use, and I've included a link to ADB right here if you want to check that out. Let me show you guys what the Rev Hardware Client looks like. So right now I'm pulling it up and I'm just typing Rev Hardware Client. It's like another app on my computer. So I'm just pulling it up right now. Now, unfortunately, I don't have access to a control hub right now with me. But what you would see, let me see if I can actually find a Google image for it. I'm going to hang on one second. Okay, so I found a couple of images here, which basically show you what you'll see in the Rev Hardware Client once you connect to your control hub. Now, a piece of information that is crucial to understanding how these pieces of hardware work is that the control hub, when you actually boot it up, will create its own Wi-Fi network, actually. So you'll be able to see, like if you check your Wi-Fi, you'll be able to see the network that your control hub has created. And what you can then do is you can then connect to this network, and then the Rev Hardware Client will figure out that like, oh, you're connected to a control hub, and you'll be able to see what that looks like. So right here, when you boot up the control hub and you connect to it via the Rev Hardware Client, you'll see something that looks like this image on the right here. So you can see right here, it will show you all the pieces of hardware that you have connected. So in this case, we have a control hub and an expansion hub, as well as a driver station, which we're going to talk about in just a minute. And you can see right here that this first tab, this update tab, it shows you what version of the firmware you're currently running for each of these pieces of hardware. So firmware is another word for software that runs on like a hardware device. And you can see that this firmware for this hub is at version 1.8.2. If your version is out of date, it will tell you that, and it will give you the option to update it. So right here, this is a really good page. If your software is out of date, you can update it right here. The other important tab is this Program and Manage, which I have an image of right here. Now, like I said, the control hub, when you boot it up, it creates its own Wi-Fi network, and it basically has its own like name and a password. When you boot up a fresh control hub, like when you just buy one and you're starting it up for the first time, that name of the Wi-Fi network is going to be something like rev dash something or FTC dash some numbers, first dash some numbers right here. And what you can do is you can actually change the name of that network to be whatever you want. So if you're on team, say 1234, you can actually change the name of the Wi-Fi network to be 1234-RC, or just something that you guys can recognize. The reason why you'll want to change the name is because when you're at competitions, or even when you're at Noble Labs, there's like 5-6 teams there. And if all of them have control hubs booted up, you want to be able to differentiate your control hub from everybody else's. So being able to like change the name so that if you're on team 1234, you can see like, okay, 1234-RC, it really helps you like figure out which control hub is yours and prevents you from accidentally connecting to somebody else's. You can also change the password of your Wi-Fi network if you want right here. So if you want to have a unique password in case you're worried about security, you can change the password here. So those two things that I showed you, the updating the firmware and changing the Wi-Fi, those are the two main things that you can do here in the Rev Hardware Client. Okay, so that's really what the Rev Hardware Client is for. It's really good for configuring your control hub and your expansion hub and for changing the Wi-Fi if you need it. Now, Rev, which is the company that makes these control hubs and expansion hubs, has excellent documentation about setting up your control hub and adding an expansion hub if you want. Really great documentation, better than I could have written. So I've included links to their pages right here in case you want to check this out. But what I'm going to do is I'm going to add, what I've done is I've put a little, just a quick summary right here in case you guys are curious for setting up a fresh control hub. So the first thing you're going to do is you're going to power up the control hub, basically connect a battery to it. And the control hub, what it does is it actually has lights on it. And those lights will blink different colors to basically give a status for what's going on. So when you first boot up the control hub, you might see that the light is blue or flashing blue. Once it turns green, That basically means that the control hub is ready to go and that it's created its own Wi-Fi network. And you should see the Wi-Fi network show up in your Wi-Fi list. So what you can do is you can then connect to that control hub's Wi-Fi network, use the Rev hardware client to connect to that control hub, and then you can do whatever changes you need. If you need to update the software or the firmware, let me actually change this. If you need to update the firmware, you can do that. Or if you need to update like the Wi-Fi settings, you can do that too. But that's basically a very, very quick thing for setting up a control hub. Again, these guys do a much better job at it, and I would highly, highly recommend that you take a look at these resources here. So the next thing I want to talk about is the driver station. The driver station is basically an app on an Android phone. And what the driver station is used for is it's used to run your OpModes. OpModes is just another word for programs, right? Your software programs that you want to run, like your teleop autonomous routines. You can connect your gamepads to the robot. You can choose what's known as a config file, which we'll talk about. Excuse me. And you can also pair it to the control hub. So the driver station is essentially how you are going to communicate with the robot. You are going to plug your gamepads, your game controllers into this phone, and that's how you're going to drive the robot. So what I have here are some screenshots of the driver station. So right here on the left, this is what the app will look like in the phone. And when you boot it up, you'll see a page that looks something like this. So there's a lot of information on this page, and we're going to go through it step by step. So the first thing we have here is this info in the top bar. This first thing right here, this 999-C-DS, this is simply the name of your driver station. Remember how I said that we can make the name of our control hub unique so that people wouldn't get confused, or you wouldn't get confused when trying to find it? We can do the exact same thing with the driver station. We can just make a unique name for it. This battery symbol right here is the battery of the phone itself. And this green box right here shows you how many gamepads are connected. So you can see that you can actually have a max of 2 gamepads connected to your phone. Right now, we just have the 1 gamepad here. But if you had 2 connected, you would see another symbol like this gamepad show up right here. Or if there were no gamepads connected, you wouldn't see anything here. Now, right here, this network box circle is very important. Basically, if you're successfully connected to a control hub, this right here, this name, will match the name that you set in the Rev hardware client. Remember, I talked about setting a Wi-Fi name right here. If you're connected properly, the name you see should match the name you set here. So that's a really quick way to determine whether you've actually connected to your control hub properly. This right here represents the battery level of the robot. It's very important that you guys keep your batteries completely charged whenever you're in a match or something. You don't want your battery to die in the middle of a match. That's, it would be quite sad. And then over here, we again have this thing, the config file, which you can have multiple of them, and then this just shows you the one you've picked. I'll get into config files more in detail in our next lesson for next week, but just to give a quick rundown of what a config file is, basically a config file is a special type of file that you set in the driver station by clicking these 3 ellipses up here, and it's basically how you tell the control hub what is connected to it. You tell it what's connected to each of its ports, and then that config file is then used by your software to link your code to the actual physical hardware. That's the lowdown of a config file. I can go into more detail about that next week, but I just want to give you a quick summary of that. So that's this section right here. Now what we have here is the last section. These, what we see in the red box is your OpMode selector. So this left arrow will have all your autonomous OpModes, and this right arrow will have all your teleop OpModes. Right here, this big white circle, this is how you actually run your programs. So you can see right here that we have our OpMode selected, my first OpMode. And what you're going to see is, so see right now, if you see the square, that means your OpMode's running. And when you press it, it will turn off, and you'll see a button called init. When you click init, it will then show you a play button. And then once you've initialized and you're ready, you can press play, and then it will turn into the square, and your OpMode is currently running. And the last thing we have right here is what's known as telemetry. Telemetry is basically information that the robot can give back to us. So we can put debugging statements in our OpModes, and we can actually figure out like, okay, what is the robot doing, and are we doing things properly? So here, for example, if we have like a motor and we want to know the power of the motor, we can actually send that motor power back over telemetry, and then we can see like what our motor power is. Similarly, like if we have a servo position, if we want to know what angle our servo's at, we can do the same thing and have it show up right here. Telemetry is a very useful tool, and we're going to be using it a lot in the course. It's great for debugging. So if you're having some problem with your robot and you're not really sure like what's going on, having telemetry is very, very important. So that's pretty much the driver station. And the last piece of hardware I want to talk about is the gamepad. So right here, this is our gamepad. It's basically the game controller, and this is how we're actually going to drive the robot. Now, each of the buttons on the gamepad is mapped to a variable in software. And each one has like a different value, a different type associated with it. So these buttons basically, like these X, Y, A, B buttons and the D-pad buttons right here, these are Booleans. They can either be on or off, right? On or off. These joysticks are floats. I think they're floats or they're doubles, regardless. They're decimal values because they can be, moved all over the place, right? So whatever value they have, it's represented as a decimal. We also have some buttons here in the back, as well as some start buttons here. And all of these buttons are actually mapped, and you can see what their mapping is right here. And the gamepad is actually how you're gonna use that to actually drive the robot during the teleop period. So what I want to do now is I want to quickly go over some intro gamepad code, just to show you guys like what is it like to actually code the gamepad? How do we use it to actually drive the robot around? So this is a very simple file that I wrote called read from gamepad. And we're going to go through it real quick just to get a feel for first of all, how we actually write software for first, like the OpModes, and also how we use the gamepad. So the first thing I want to draw your attention to right here is this. So this is our class definition. We're making a class called read from gamepad, and we are making it a linear OpMode. There's two types of OpModes. There's, let's see right here, it should be in the samples. There's a linear OpMode and an iterative OpMode. Now you can use either one, but I've always found that linear OpModes are just easier. And so most of the programs that I will be using for this course will be linear OpModes. If you are curious about iterative OpModes, you can go to this file right here, iterative, and you can check out what one looks like, but I'll just be using linear OpModes. So we have our class read from gamepad, and notice that the name of the class actually matches the name of the file. This is a requirement. The file name has to match your class name, otherwise it will complain. The first thing we have is this run OpMode method. Now, one of the caveats of using a linear OpMode is that there are some methods, some functions that are required. And one of those required functions is run OpMode. If you do not have the run OpMode method, your program will fail. So you just need to have this method. And that's why we include this @override flag, because we're overriding like what the traditional thing would be. It's more of an abstract class thing. It's not super important. Just for all intents and purposes, you can just put the @override flag and you'll be fine. The other thing I want to draw your attention to is on line 11. We have this teleop flag here. This basically tells the phone, the driver station, that this is a teleop program, and it should appear in the right side instead of the left. If you instead put @autonomous here, so if I just put @autonomous, then this program would instead appear on the left side. But this is a teleop program because we're controlling it ourselves. The robot's not moving by itself, so we're going to make it teleop. Now, what I do here first is I use some of that telemetry. So this is how telemetry works, right? Telemetry, what you do is you first have to add data to the telemetry. Basically, what statement do you want to appear on the phone? So you add whatever telemetry you want to add, and then once you've added all the data, you can update it. And when you call this update function, it actually gets sent to the phone. Think of telemetry almost like writing an essay. We are adding sentences to our page, okay, however, whatever our essay is, and then think of the update function kind of like printing your essay. So once you've added all the information you want on your essay, like say you're ready to turn it in, you can print the essay and then it's ready to be like shown to your teacher or whoever. That same principle applies here. Once we've done this, we call this wait for start function. Think of the wait for start function as a wall, right? Imagine like a physical wall right here. No code will pass this wait for start. Like the program actually won't progress past this wait for start function until the start button here is pressed. So remember how I said that when you actually have the driver station up for the first time, you're not going to see like a play button, right? Instead, you're going to see something that says init. It's a two-step process to actually run an OpMode. We first have to initialize the OpMode. It's called initting, and then we actually run the OpMode. When you press init in the white circle right here, any code that you have before the wait for start will run. So for example, these two telemetry statements, because they are before wait for start, they're going to run. And actually, that's why I have this status initialized. So once I've pressed the init button, the robot is initialized. Once you press the play button, the wall goes away, and then the rest of the code is good to run. So in this program, what I'm doing is I'm actually capturing some of the data from the gamepad and putting it onto the telemetry. So I'm looking at the joysticks right here. And each joystick, as I put in this comment, is represented with two values: a forwards and backwards position, moving the joystick up and down like this, and a left-right position, so moving it left and right. And what I've done is I've created 4 variables to represent each of those movements. So I have this left stick forwards backwards, so whenever the left stick moves up and down. I have this left stick left right, for whenever the left joystick moves left or right. I have another one for the right stick too, so up, down, left, right. And each of that is captured in these 4 variables right here. The next thing we have is a while loop. And this while loop, because I have this while OpMode is active, basically what this while loop does is it runs for the duration of your match. So OpMode is active, basically is constantly checking whether the stop button has been pressed. Until the stop button on your phone has been pressed, like once you've actually are done with the match and you want to stop the robot, this code will keep running and it will keep running. Once you have pressed the stop button and you've actually stopped the game, so once you see once you've pressed this button, this will stop running. But while the OpMode is active, while you're actually driving the robot around, this will keep going. So right here, what I'm doing is I'm taking these 4 variables I made and I'm assigning them to different variables of the gamepad. So you have 2 gamepads that you have access to, and these are actually built-in types from first. So if you're curious and you want to take a closer look, basically, at all of what the gamepad has to offer, what you can do is to get to this. Actually, I should specify what I just did here. I went a little bit fast. What I did was I first pressed the control key on my keyboard. Then I hovered over this variable. You see how it turns blue? Then I left clicked it with my mouse. And what that does is it takes me to this page right here, OpMode internal. So you can see that just built in from the first package, we have 2 gamepads built in. We also have the telemetry built in as well. And this is what I was talking about before when I said that there are 2 gamepads that you can connect to. Each of these gamepads is already made in the software. If you want to see what variables you have access to, you can do the exact same thing. You can press the control key, hold it, and press left click, and it will pull up the actual definition of the gamepad. We call this a class definition. And you can see right here, this is all the information, but right here, this is what's really going to matter. All of these variables are already defined. So for example, the left analog stick horizontal axis is the x-axis of the left stick. The up and down motion of the left joystick is this variable right here. We even have variables for all of the different things on our gamepad. So we have D-pad up, down, left, right, corresponding to these buttons right here. We even have our letter buttons, this A, B, X, Y, which corresponds to this right here. So whenever you want to capture data from the gamepad, you can use these variables. But let's see what that actually looks like in code. So basically what I'm doing right here is I'm calling gamepad 1. Gamepad 1 is any gamepad that is in this position. So see user 1, this gamepad, this is gamepad 1. Any gamepad right here, if there was another one connected here, this would be gamepad 2. So I'm taking data from gamepad 1. I'm specifically looking at the up and down motion of the left stick, this forwards, backwards, and I'm putting it into this variable. I'm doing the same thing for the left-right motion of the left stick, and I'm putting it in here. And I basically just repeated this for my right stick as well, my right joystick. And finally, what I'm doing is I'm taking some telemetry, right? I'm adding some more telemetry. So I have my left stick forwards, backwards. This is just to make it look pretty. This basically means that I'm limiting the output to 2 decimal points. And I'm taking my data. So left stick forwards, backwards, left stick, left, right. I'm doing the exact same thing for the right stick. So this right here is how we access the different fields of the gamepad. This is how we actually get data from the left stick, the joysticks, and we can stick it in our variables. I've put another example here just for added knowledge about in case you don't want the joysticks, in case you want to say the buttons, you can access those variables directly and put it in right here. And what you'll see is that this data will actually show up here in the telemetry. And remember, like with the essay and the printing example, once we've added our data, we can then print it. And what's going to happen is because this is in a while loop, this will keep updating over and over and over again. So as long as the OpMode is active, we can move the joystick however crazily we want. We can press the buttons up and down all we want, and it will constantly update in real time. So this right here is a very good program to study if you're curious about how the Gamepad works. You can easily take this example right here, and you actually should have your own branch now, so you can experiment all you want. So like, for example, let's say you want to get a little crazy. You want to play around with this a little bit. You can add some more data. So you can say, like, I don't know, say you want to check out the B value of the button. You can just add another telemetry statement right here, like button B. Okay. And then right here, you can say, like, gamepad 1.B. And there we go. And now what I'm going to do is I've just captured the B data. And then we put a semicolon at the end. So you can play around with this as much as you want. If you have access to a phone and a gamepad, you can actually see these updating in real time. I don't have one with me, unfortunately, but I know this code works because I ran it in the class last week. But this is essentially how we capture data from our gamepad. And we're going to use the gamepad, basically our stuff here, to build onto bigger projects. For example, instead of just printing the gamepad values to the phone screen, what if you use them to drive a motor, make a motor move, or to move a servo a little bit? Or what if you use the gamepad to actually make the robot drive, move back and forward? There's a lot of different things you can do. And we're starting with the gamepad because it's the simplest piece of hardware, and we're laying a foundation for what you can do later. So that's pretty much everything I just wanted to cover. That was everything we covered in week 3. Next week, we're going to look at, like I was saying, how we can use the gamepad with motors to do very complex things. Thanks for watching. Leave a like, subscribe, comment if you enjoyed this video and if it helped you. And I will see you next time. Have a good day. Goodbye.